Good morning, students of class 9. Today again I will explain another video. Okay, in this video I will explain mainly about some important calculations, okay, in chapter number 4, that is structure of atoms. Okay, now before I start explaining this video, please take out your notebook, pen, pencil to copy down this important calculation. Okay, let's start these calculations of this chapter number 4. Okay, now first and most important part is you need to remind, that is you need to by heart the atomic number of elements from 1 to 20, right? Now first atomic number is most important, okay, for calculating each and every process. Okay, say for example, calculate one question, say calculate the valence of, say number A, sodium, number B, say oxygen, number C, say aluminium, right? Number D, say calcium. How can you calculate this valence of these elements? But don't forget to by heart the atomic number, right? Now look here, for calculating this valence, the most important part is we need to understand about the electronic configuration, right? We need to understand about the electronic configurations. Okay, now shall I start? Ready? Okay. First, number 1 answer, number A, sodium. The first and most important part is the atomic number. Atomic number of sodium is 11, right? Electronic configuration of sodium is atomic configuration that distributed this 11 into their respective cells, right? That means 2, 8 and 1, right? This is only 1, right? That's why the valence of this sodium becomes 1. Therefore valence of sodium is 1. Don't confuse, don't forget. Okay. Next, number B, oxygen. In here also, atomic number of oxygen atom, okay, is 8, right? Electronic configuration of oxygen is 2, 6. Look here, the 6 is more than from the 4, right? Because of that, therefore the valence of oxygen is, this 6 is more than from the 4. What can we do? Then we should minus 6 from this 8, okay, is equal to 2. Therefore the valence of the oxygen is how many? 2. The main important for calculating or for finding the valence is what? That is the atomic number. If you don't know the atomic number, then you don't know how to calculate the valence. Okay? Please copy down. Done? Okay. Now, next, number C. Number C, that is what? Aluminium. Atomic number atomic number of aluminum is 13. Electronic configuration. Electronic configuration of aluminum is 283. Why? This aluminum, okay, 13 atomic number is distributed into the 3 cell, 2, 8 and 3. Right, the outermost is what? 3. Okay, now this 3 is less than from the 8, then we will go directly for valency. Now, therefore, the valency of aluminum is 3. Right. Next, number D. Calcium. Atomic number of calcium is 20. Calcium has a 20 atomic number, right? And now electronic configuration. Electronic configurations of calcium is 2882. Okay, it will be distributed into the 4 cell. Okay, K cell, L cell, M cell, and N cell. The outermost is how many? 2. Okay, then therefore the valency of calcium is 2. Let's copy down how to calculate the valency. Okay, the first part. Then, okay. Now, this atomic number is equal to number of proton, is also equal to number of electron. Don't forget, atomic number is equal to number of the proton is equal to number of the electron. Atomic number is indicated by capital letter Z is equal to P is equal to E. Right. Again, atomic mass. Atomic mass. The another name of atomic mass is also known as mass number. Okay, is equal to number of proton plus number of neutrons. Right. Now atomic mass or mass number is indicated by A is equal to P plus N. N is number of neutron. Right. And then this A is also equal to Z plus N, since P is equal to Z. Right. And here A is also equal to E plus N. Why? Since Z is equal to E is equal to P. Okay, because of this, what will happen? This A is equal to P plus N, or A is equal to Z plus N, or A is equal to E plus N. Don't forget these relations, okay? This relation is used to calculate the mass number, number of the neutron, and atomic number. Okay, let's copy down this important formulas. This also important, right? Then okay. Then right. Now look here. I'll give the one this question. Composition of nuclei of two atom. Compositions of nuclei of two atomic species. Two atomic species. Okay. X and Y is given below. Okay. Now look here. Here X, here Y. This is the proton. Okay. And this is the neutron. Proton and the neutron. Look here. How many protons in this X? X is also 6 proton. Y is also 6 proton. Okay. And this what? This neutron in here, X is the 6, Y is the 8. Right? Don't confuse. The number of the proton in X is 6, Y is also 6. The number of the neutron in X is 6, Y is the 8. Okay. Now give the mass number of X and Y. Give the mass number of X and Y. And then is calculate the mass number of X and Y. Okay. And also what is the relationship between the two species? Okay. What is the relation between two species? Okay, this is the question. Please copy this question first. Done? Okay. Now I will start this solve portion. So now look here. Answer. Okay. We know that what we know, mass number is equal to number of proton plus number of neutrons. Right. Okay. Now mass number of X is equal to how many these protons are there in X? 6. Neutron how many? 6. That is equal to how many? 12 unit. Right. The mass number of this X is 12 unit and mass number of Y is how many proton? 6. How many neutron? 8. Is equal to how many? 14 unit. Okay. This is the first part of the equation. The second part of the equation, see, both the number of the proton is equal, but the difference is only in the mass number. Right. That is, number of atomic number is same, but different in the mass number. And this is known as what? What? Yes, isotope. Okay. Now, these two elements, these two atoms, these two species, okay, these two atomic species, okay, have atomic number, what? That is 6, right? Understanding? That is how many atomic number? 6, but differ in mass number. Okay, mass number different. That is, one is what? That is x is 12 unit and y is how many? 14 unit. Okay, therefore these two species are this what? Isotopes of same element. These three species are the isotopes of the same element. That is isotope of the carbon. Okay, that is carbon 12 and the carbon 14. Okay, this is the answer. Please copy down. Done. Okay, the last question for today I will explain. That is calculations of average atomic mass for chlorine. Okay, this is one of the most important. Okay, calculations of average mass number of chlorine. Okay, the first most important part is chlorine has two isotopes. Okay, the first one is chlorine 1735. Okay, chlorine 1735, right? This is what in here mass number 35 unit, and it is okay 75%. Okay, available in nature. How many percent this chlorine has available? This chlorine has available in nature 75%. The another one chlorine C17 is 37. Okay. Mass number how many? Mass number, the upper one indicates the mass number. Okay. That is the 37 unit and it is okay 25%. Okay. Available in nature. How many percent is available in nature? 25%. Okay. Now average mass number. We need to calculate the average mass number. Now look here. Average mass number is equal to average mass number of chlorine is equal to this 35 unit contributes how many percent? 75%. Now that is 35 into 75%. Okay, that is this 35 contributes how many percentage? 75%. Plus with 37 into 25% unit. Right, that is this 37 units, they contribute how many percentage? 25%. Okay, now look here. This means 35 into 75 by 100 plus 37 into 25 by 100 unit. Okay, first you multiplied these two. Okay, these two multiplied and these two multiplied. Okay, look here. 75 into 35, 5 are 25, 2 in hand, 35, 37, 15, 1 in hand, 21, 22. means 5. How many becomes 2? 6, 2. That means 2, 6, 2, 5. 2, 6, 2, 5. Now again another one is 37 into 25. 5, 7, 35. 3 in hand. 15, 16, 17, 18. 14, 1 in hand. 2, 6, 7. It becomes 5, 2, 9. 9, 2, 5. Okay, you add 2, 6, 2, 5 plus 9, 2, 5. 0, 5. Okay, it becomes how many? 5. It becomes 3. That is equal to 3, 5, 5, 0 divided by 100. Okay, if you divide this 3550 by 100 becomes 35.5 unit. This is the average atomic mass or mass number of the chlorine. Okay, now don't forget, in your textbook or any other textbook you can find the atomic mass is 35 of chlorine is 35.5, not this 37 and 35. Okay, that means after taking the average of these two, we will get how many? 35.5. Okay, this is the mass number of the chlorine. Okay, this is the one of the most important calculations, okay, part of this chapter. Okay, if you have difficult or any problem, please let me know. Okay, please send one message to WhatsApp group. I will clear it out. Thank you and have a nice day. Bye bye.